Hey guys, welcome to this session by K21Academy. In this session, we will try to understand about Docker networking and also we will perform some hands-on labs. Also guys, before moving on with this session, please subscribe to our channel so that you will never miss an update on our upcoming videos. Now let us take a quick glance at the agenda. Firstly, we will be introduced to Docker networking and types of Docker network. And then we will learn about bridge network and also we will have a demo on working with Docker bridge network. Post that, we will learn about host network. Also, we will have a demo on working with Docker host network. And then we will learn about MacVLAN network. Post that, we will try to understand Docker network commands. Also, we will be having a demo where we will be working with Docker network commands. So we have taken a clip from one of our certification training program on Docker and Certified Kubernetes Administrator, which is CKA. And in this clip, our expert will talk about Docker networking.
Hello and welcome to this video. In this video, we would be discussing about the different types of Docker networking. So Docker networking has been a pluggable type of subsystem, and there are different sorts of drivers which can be used to set up the networking across containers on the Docker host. And how can we find what all drivers are supported? You can execute the docker info command on your Docker host, and in the plugin section you can see there are different types of plugins which are supported for this type of this particular version of Docker. So here you see bridge, host, IPVLAN, MacVLAN, null and overlay type of network, right? So we would be seeing few of these type of networks. By default, as soon as you create Docker host machine and you install Docker on that, there are three networks which gets automatically created. One is the bridge type of network, second is the host, and third is the none type of network. So bridge network is the default network driver which is chosen in case you don't specify any parameter while creating a container. You don't mention which network you want that container to get created in, then it takes the default network. The host type of network is in when the container replicates the complete host's network stack and starts behaving as if it's the host itself. So whatever would be the IP address of the host, that would be the IP address of the container in case of host networking. And the third one is the none type of networking, in which the container's complete networking is disabled. It can't communicate to any container on that host. By default, if we are thinking of a Docker machine, and till now we are confined on a single server, right? We have a single Docker host and we are creating containers in that. So the ability to communicate across Docker hosts is not there with a simple Docker type of software. For that, you have to take cluster type of software like Docker Swarm or Kubernetes. Then only the containers running on Docker host 1 can communicate to containers running on Docker host 2. So there's a limitation with the Docker that it can't set up inter-host communication. Let's understand how does the communication happen when containers are on the same host. So I can create container. So this is my Docker host machine in which I am running Docker daemon. Docker software installed, Docker daemon is up and running. So by default, I have bridge type of network. This is the bridge network which is created by default. And this bridge is actually created on the Linux level. This is a Linux bridge and it is named as Docker 0 on the Linux level. I'll show you all these things on the command line as well. Using the bridge utility commands, we can dump and see that it is actually the Linux bridge which is present, but on the Docker level it is called as default bridge, and on the Linux level the name is called as Docker 0. You can create multiple containers on that bridge. So when this bridge default got created, it has a subnet associated with it. It has a gateway IP address, and from this subnet, this container would get an IP address. Like for example, the IP address would be like this in case you have 172.17.0.0 as the subnet range. And if I create container 2, so this is marked as container 1, and I create container 2, it would take 172.17.0.3. Gateway takes the 0.1 IP address, and from there the next IP addresses are grabbed by the containers launched on this bridge. So what happens? This Docker machine actually has an Ethernet interface marked as ETH0. And whenever a packet would come on this, it should fall on the bridge, and from the bridge it will go to the container. But at this point in time, we are not exposing any ports of this container. So we are keeping it simple. We are just thinking of containers communication within that network. We are not going outside the host. So containers on the same bridge can communicate to each other. So you can communicate from C1 to C2 and C2 to C1. That's by default possible. There is no nothing that which we can stop it. So this is an isolated environment. If you see, this is an isolated environment. This bridge is an isolated environment, and how many ever containers I create on the bridge, they would be able to communicate to each other. Okay, and you can create your custom bridges as well. So let me pick up a different color, and I am creating a custom bridge called as custom bridge itself. The name is custom bridge. So let me name it as custom bridge, and I create containers on this custom bridge. Then what would happen? These containers, let me name it as C3 and C4. Even though they are on a different bridges, on one Docker host, the container name and the container ID will be unique. You can't say that I'm creating container on a different bridge, so it will be again named as C1 and C2. It can't be possible. In one Docker host, all the containers should have a unique name. So this is the custom bridge, and you can define a subnet like this for it, and let this container get assigned with, it should be 18.0.2 and 172.18.0.3 as the IP addresses. These two containers can talk, but communication across networks is not there, because when you want to communicate from one bridge to the other bridge, you need a gateway bridge type of thing, which is not there with default Docker installation. So inter-bridge communication is not possible in case of simple Docker software which we have. And we will see when we go to Kubernetes level how these things can be resolved. This is a limitation on the Docker level, right? And one more thing we need to understand, the ingress and the egress traffic. So we will talk about egress traffic. We talk about the ingress traffic once we expose a port and you want to communicate outside. That time we will discuss about it. Now understand that if a container is created, by default the egress is enabled and it can communicate outside the network. So this is by default enabled type of thing. From my container, if I want to reach outside, I should be able to reach without doing anything. There is no changes needed. It takes the ETH and it goes out. So we will see all these things. We would be able to ping across containers. We would be able to ping google.com once our container is up and running. And we would see that this communication is not possible, but the communication within containers on the same bridge, that is pretty possible. Okay, so let's quickly run through our slide. We will see the bridge type of network. And in this bridge type of network, we can create an isolated environment for a set of network which want to communicate with each other, and communication outside the bridge to any of the containers is not possible. It is completely isolated for that particular bridge. We cannot modify any of the settings for the default bridge because it is already created with the Docker daemon when the installation is done. And if you want any different IP address range for your container, you want to customize anything, you can rather create a custom network. So in this picture, you would see that I have depicted a custom bridge called as my bridge, and there are two containers running on that, which is like the DB and the web. So DB has got .2 IP address, web has got .3 IP address, and they both are hosted on the bridge network called as bridge, and that falls down to this Ethernet interface, which is the ETH0 interface of this server. So let's quickly see how do we work with the bridges and the containers. So because we will have to see whether the bridge name is Docker 0, what all bridges are there, we would quickly install. I'll just do an apt-get update on this server. Let me do sudo apt-get update with a Y, with a -y so that it doesn't ask. Okay, there's a typo. There has to be a P. My bad. Yeah. So let this update, and then I would install with apt install command. I would install a utility with using which I can run some bridge based commands called as bridge utils. So this will help us execute bridge related commands like brctl show. This would list all the bridges in this network, in this Docker host. If you see, there is a bridge created called as docker 0, and this is the bridge ID. So let me clear the screen and show you the IP address. IP address, the short form can be this IPA, and with this you would see that docker 0 is there and ETH0 is also present. So ETH0 is the default interface, the first interface of the Docker host machine. Our Docker server is having only one Ethernet interface card, and that is assigned the ETH0. And Docker 0 is the bridge which is by default created. Okay, so let's create a container, and we would not specify any -- network option, so that should get created on the default bridge. So I'll quickly do a docker run -dt. I'll give Ubuntu and I'll give a bash. So let me do this. So it's created. Let me check docker ps. Yes, it's up and running. So let me quickly show you that on the bridge there would be a new Ethernet interface created. How our virtual machine has a default Ethernet interface, same way container also would have an Ethernet interface, and that gets listed over here. This is the container's Ethernet interface. Container is also serving like a server, right? So container, you can imagine that is like a server, and it has an IP address associated to this Ethernet interface. Let's find out what is the IP address of this particular container. For that, you will have to do a docker inspect, and you will have to give the network ID. Let me pick the network ID from here. And if you see here, the container section is there. Let me quickly show you from the top. It says bridge type of network. This is the ID. The driver is bridge. And here, if you see, there is a container section. And in this bridge, how many ever containers are spun up, they would be getting listed here. So we have just executed one container is running, and that container gets listed over here. If you see, the IP address associated with that container is this. So my container's IP address is 172.17.0.2 at this point in time. Okay, so if I create one more container, let me create one more container quickly and verify with docker ps command. And I should be able to see there is one more Ethernet interface. So on this Docker bridge, there are multiple Ethernet interfaces listed. And if I go and do an inspect on the bridge, I should see two containers now, one with the .2 IP address and one with the .3 IP address. So there are two different containers running on the same bridge, and they have two different Ethernet interface, their respective Ethernet interface and IP addresses attached to that Ethernet interface. Okay, so let me quickly get inside one of the containers using a docker exec command, or even you can do docker attach because you have created with bash as well. Let me pick the container ID. Let me take .31 and I'll say bash. So I should be inside the container. I don't have by default the ping utility. So let me do an apt-get update and install iputils command ping to package, so that I am able to ping to outside world or to the neighbor container which is running on the same network. So I have updated. Let me do an installation of the package. So for Ubuntu, the ping utility is in iputils-ping package. Let me say yes, and it has downloaded. Let me show that by default egress is allowed, and I should be able to ping to google.com. This is one thing. Plus, I should be able to ping to the other container which is running on the same bridge. Okay, so I should be able to ping to .2 from here. Cool. And if you can see the IP address inside this container, you will have to install ifconfig if I can run, or ipconfig if I can run. Let me check. No, these utilities are not there in the bare system, the bare operating system which we have picked up. We just installed the ping utility so we could be able to ping. So this particular exercise showed us that you are able to ping from this container to outside world, which is by the google.com ping, and we are able to ping to the neighboring container running on the same bridge. Let me exit, and there are two containers running on the same bridge. We saw with the docker inspect command, right? And I was able to ping from this container to this container. I'll leave this containers running, and we would see the custom bridge creation, and then we would see how do we work with it. So let me create a custom bridge. So docker network create is the command for the creation of any network, and let me name it as custom underscore bridge. And I'm not specifying any the subnet range and all that. Then it picks up some default values and it automatically assigns the details to it. So let me do docker network ls to list the bridges and the other networks. So here, if you see, this bridge network which we have created is getting listed, and if you do a brctl show command, you should have one more bridge now, and this is the bridge name. If you say it has taken br and it has taken the bridge id and given it a unique name, and if you create containers on this bridge, then you would have interfaces created on that and IP addresses assigned from this bridge to those containers. Let's quickly do that. So whatever command you executed for creation of container, you would just give hyphen network, one more parameter to it, and say hyphen network and give the name of the bridge or the ID of the bridge, anything would do. So with this, the container is created. And let me do docker ps. Yes, it is up. Let me create one more container so that I can show you that within the custom bridge also the containers can connect to each other, but from custom bridge to the default bridge, when I try connecting, it's not possible. So I have totally 4 containers running now, 2 on the default bridge and 2 new ones on the custom bridge. Let's quickly inspect our custom bridge and see the container IP addresses. If you see, there are 2 containers running, one with .2 and one with .2 and one with .3 IP address, and one with .2 and one with .3 type of IP address. Let me quickly get into one of the containers. Let me pick the container ID. Yes, and I would say bash, and I am into this container. So I am into .3 container at this point in time. I've picked up this container ID. I'm inside .3 container. Let me quickly install ping utility to see whether I am able to ping. So first I'll do an update, and then I'll do apt install. Sorry, there's a typo. Install iputils -ping, and I can give -y here itself so that it doesn't prompt for yes and no. Okay, cool. It has done the installation of the package ping utility. Let me ping google.com. Yes, even on the custom bridge, the egress is by default allowed. Let me ping the container on the same bridge. 172.18.0.2 is the other container. It's able to ping the container on the same bridge. Let me ping the container on the default bridge, and you would not be able to ping because bridge to bridge communication can't be established. Default Docker software, the Docker, it doesn't have the provision of establishing a gateway bridge. When bridge and bridge communication has to set up, there should be a gateway bridge between them, and that's no provision for any gateway bridge. So this shows that we can create custom bridge, plus we can communicate across bridges. Communication is not possible, but within the same bridge, multiple containers can talk to each other. So bridge is actually establishing an isolated environment, and containers on that bridge gets the IP address on that particular subnet range. Quickly, I'll exit from here and do a brctl show command and show you that there are two different Ethernet interfaces on this bridge network as well now. So two containers running on the custom bridge, two containers running on the default bridge. So in host networking, the complete network stack of the host gets replicated inside the container. So containers network stack is not isolated from the host. Rather, it starts behaving as if the container itself is the host. Okay, so it doesn't have its own IP address allocated. Rather, if you see in this particular example, the host IP address is 192.168.0.1, and that becomes the IP address of this container. What advantage are we getting out of this? In case we want to optimize the performance, we would be able to process the packet much more quickly, because here, if you see, this is the public IP address, and even this is the public IP address which is there. And when you want to handle a large range of ports, like I don't want any NATing happening, network address translation, then I can go with such type of network. Okay, and this does not require the NAT translation, as I mentioned. So let's see how do we work with it. Let me first explain you in the pictorial representation how different it is from the normal bridge type of network. So this is my Docker host, and it has Docker daemon running. This is my Ethernet interface, and this Ethernet interface is having a public IP address. This is the IP address of my Azure VM, right? And if I create containers on the Linux bridge, on this bridge, any type of bridge, right? Whether it be a custom bridge or the default bridge, if I've created container 1 gets the IP address in this particular subnet range. And we had seen that it got an IP address of this. And if I want to reach from outside, then the connectivity is a bit different, right? So here, if I have to send packet to this container is not reachable from outside. That is the difference, and I will have to reach the Docker host first at this IP address, and then from here fall to the bridge, and from the bridge it has to go to the container. But if it falls to this bridge should be in a position to understand to which container it has to send, because it would be having a lot of containers running on that bridge, right? So we would see this external connectivity in further examples. But in this video, we are more interested with host type of networking. So I am creating a container. There is no bridge like this. I'm directly creating a container. I'm denoting it with a square box, and I'm saying it as C2. And this is on -- network called as host. When I create, I specify the parameter this way. So what happens? The IP address of this container becomes the Azure VM, same as the Azure VM's IP address. And that is the reason it says it replicates the network stack of the host. And if you reach the host, that means you're reaching this container automatically. There is no falling on the bridge and translating from the public IP address to the private IP address, which happens in case of the bridge. That is not there. Rather, this IP address is the same. So if I'm running any application like Nginx over here, and I say I'm listening on port number 80, then you can reach this application directly on Azure VM's public IP address with :80. When you do that, you actually reach directly to this container. Advantage if I don't want to do the public IP to the private IP translation, because obviously there would be a latency in this translation happening. And example, like I used to work on a telecom project, right? I was working with big telecom providers, and we normally make video conferencing calls or any phone calls, and we don't want any latency to be there in those calls, right? So if we fall like this in such type of application, there would be a huge latency. So what we do, we create containers directly on the host network, and we can use this. There is advantage to this. We are optimizing the performance. That is the advantage. There is disadvantage associated as well. The disadvantage would be that your container is completely exposed to the outside world. Whoever can reach your Azure VM can reach your container now. Can I spin multiple containers on the host network? Yes, you can. Here also you specify network is a hyphen network is host, and I'm spinning up container 3, and I can listen on a different port. I can't listen on port 80. I will have to listen on a different port, because this port number 80 actually gets allocated on the host machine, right? So 2 container listening on the same port will not be allowed. So I can reach container 3 with Azure Virtual Machines IP address with port number 80, and I can reach container 2 with Azure Virtual Machines port number 80. So we will quickly do this exercise and see how do we spin up the stuffs. So I am on my Docker host, and let's check if we have the default host type of network. Yes, it is present. Let's quickly create a container on that network, and you would give -d, you will give -network with host. This is the parameter you specify, and let me name the container as my_nginx. Okay, and I'll give the image name as nginx. So I'm picking up nginx image, and I'm spinning up a container, and I would be naming the container here with -name. I am naming the container actually. So with this, I can spin a container. Let me do a docker ps and see whether the container is up and running. Awesome, this container is up and running. And how can I reach this container? I'll have to pick my IP address of my Azure virtual machine and go on port number 80, and then I can be able to reach this particular container. Let's quickly do that. This is my Azure virtual machine's IP address, and for port number 80, normally you don't have to specify. By default, it takes the port number 80, and you see this welcome to nginx is serving, and that is not serving on this host at this point in time, right? That is serving from this container. Hope this is clear. And we would stop the nginx container which we have started, so that in the further exercises it doesn't cause any impact, and stop this, otherwise the port 80 would showing up busy, and you can't use that port 80 with any other container going further in further exercises. So please remember to stop your container before continuing with the next exercise. MacVLAN type of network. This is another type of driver plugin which can be used to establish networking for the containers, and MacVLAN is normally used when you want to directly connect to the physical network. So in this as well, you would see there are 2 different VLANs on to which my host is connected, and it has 2 different Ethernet interface phases with respect to those MacVLAN. So ETH0 is now divided, having 2 portions, one for the MacVLAN 10 and other for the MacVLAN 20. And one belongs to this green VLAN and the other belongs to this blue VLAN. And if I want to create a container on the DB container on one of the VLANs, if you see the IP address is 192.168.10.2, that comes from this IP address range, and web has got the IP address from the blue VLAN's IP address range. So instead of having the basic networking, if we are taking MacVLAN type of addressing or the networking, we assign a MAC address to each of the containers virtual interface. How we had the vEth associated with an IP, now you will have a MAC IP address as well. And this also optimizes the performance. It's normally used with legacy application where MAC address is a mandate so that you can talk to those applications. So this was all about the MacVLAN type of network. Let's quickly run through the basic set of commands. Docker network create is the command to create a network. If a network is present and if I have a container up and running and I want to connect that to a different network, let me show you how we do that. And that time you can give a command called as Docker network connect and connect a container to a different network as well. So let me show you as in pictorial representation what we would do in the demo. So this is my Docker host, the Docker Azure virtual machine, and I have two containers, C1 and C2, running on the default bridge network, getting the IP addresses from the bridge. So I'm just marking ETH0, and then I have a custom bridge on which I have C3 and C4 running. How our virtual machine can have multiple Ethernet interfaces and have IP addresses associated on that Ethernet interface, same way our containers can have multiple Ethernet interfaces. At this point in time, we just have the ETH0, and the IP address of ETH0 is having the IP address of this particular subnet on which we have created the container. Like the ETH0's IP address, it belongs to this custom bridge subnet, and for container 2, the ETH0's IP address belongs to this default bridge subnet. Let me show you if we want to create one more Ethernet interface, and I will say that this particular container C3 wants to connect to the default bridge, then it will get an IP address from this NAT. So here, if you say Docker network connect, I'm just writing in the short form. If you say Docker network connect and if you give the bridge and the container ID as C3, it will automatically get an IP address allocated in this range and an Ethernet interface. In the last exercise, we saw that from C2 to C3 communication was not there because they were on two different bridges. But on this IP address, like it had got 0.2 IP address, this has got 0.3. I'll write the complete so that there's no confusion. Okay, so here it would get 172.17.0.4, and for this Ethernet interface, the IP address would be 172.18.0.2, and this container has 18.0.3. So if I want to communicate via this IP address to these two containers, I should be able to communicate. This communication is possible. But if I try to reach on this IP address, that communication is not at all possible. So let's quickly connect to the network and show you. Let me first confirm what all containers are running in this machine. Awesome. There are two containers running on each of the networks actually. Let me quickly do inspect on the bridge. Yeah, so let me pick this container and connect to the custom bridge. Docker network connect. You will give the bridge details to which network details which you want to connect, and you will give the container ID and say done. Command is executed, and so quickly the Ethernet interface and the IP address is got. So if you want to inspect, we will have to inspect the custom bridge because this container would get listed on the custom bridge as well. So let's quickly see the name of the container and the ID of the container. ID we have seen F6ABB. The name of the container is Pandemic Current. So let's do a custom bridge inspect. And you should have Pandemic Current, and this is the IP address, and this is the IP address, and this is the container ID. So now my same container belongs to two different networks and has two different IP addresses associated of two different networks altogether. So now if I do a brctl show command, you should have 3 Ethernet interface here and 2 Ethernet interface on the default bridge. And the third Ethernet interface is for the same container, which is belonging to 2 different networks at this point in time. So let's run through other commands. In case I want to do a disconnect, I just want to remove that Ethernet interface from a specific network, I can do that. The command is to disconnect from that network. We saw the inspect command, with that you get more details about the network. You saw the ls command, with that you list all the networks. In case there are networks on which containers are not running, not the default ones, the ones which you have created, the custom ones, you can do a network prune and you can remove all unused network. In case your network is used by any of the containers, it will give you an error. It will not allow you to delete those networks. Individual network deletion can be done with Docker network rm command, and prune will only remove the unused type of network.
So we have put down everything about the certification, including the basic concepts that one should know everything like microservices and Docker, networking, storage and app stack in Docker, Kubernetes architecture and installation, security, troubleshooting and high availability, networking, deploying, application stack and advanced networking. In this 12-week roadmap, we take you from basics to advanced level along with the tips and resources for clearing the certification exam. We also have a separate team working for CV preparation and on-job support. So if you want to become Docker and certified Kubernetes administrator and want to learn right from basics to expert level, then we have a comprehensive step-by-step training for you that includes hands-on labs, including exam preparation, and the most important part, 1 year on-job support. If you are interested in this program, then I would highly recommend you to attend our free class, which covers most of the topics like why learn Docker and Kubernetes. And under Docker, you will be learning what is container in Docker, Docker architecture. And under Kubernetes, you will be learning what is Kubernetes, why to use it, Kubernetes architecture and pods, highly available and scalable applications, and many other topics. So if you are interested in attending this free class, you can visit K21Academy.com/Kubernetes02. You can also find the link in the description.